Welcome to the pre-training program for the Petrol Engine Management Checking module. This pre-training will provide you with the knowledge necessary for participation in the course at the training centre. In a four-stroke engine, only the power stroke accelerates the engine. This power stroke is caused by a pressure increase due to combustion. Combustion is a reaction between a combustive agent and a fuel used to produce energy. The combustive agent used in an engine is ambient air. Air consists of the following gases: 79% nitrogen and 20% oxygen. The remaining percentage comprises rare gases. The fuel is a mixture of hydrocarbons. Hydrocarbons consist of two elements: hydrogen and carbon. The octane rating is a characteristic representing the quality of the fuel. A fuel with too low an octane rating will ignite during compression and before the plug ignites. In this case, combustion is not controlled. A fuel with a correct octane rating will ignite when the plug ignites. In this case, combustion is controlled. This rating determines the ability of the fuel to self-ignite. The manufacturer's recommendations should be observed. The burnt mixture must satisfy three requirements to enable combustion to be as complete as possible. To be combustible, the air-petrol mixture must be gaseous. In fact, petrol in its liquid state burns with difficulty. The injector spray is used to transform the petrol to its gaseous state. A homogeneous mixture is a mixture whose composition is identical throughout. The homogeneity of the mixture influences the speed and quality of combustion. The ideal proportions equate to a mixture of 1 gram of fuel for every 14.8 grams of air. Under these conditions, all of the petrol and the air is used for combustion. Conversely, too great an excess of air will not support combustion. Combustion is also impossible with an excess of petrol. Richness is the ratio between the actual proportions and the ideal proportions. At the ideal proportions, the richness is therefore 1. If the mixture contains more fuel, the richness increases. The mixture is rich. If the mixture contains less fuel, the richness decreases. The mixture is lean. Lambda is the inverse of richness. At the ideal proportions, lambda is also 1. Lambda reacts inversely to richness. Of all the possible proportions, only a limited range of proportions is used for each operating phase. Efficiency proportions equate to a lean mixture of 1 for every 18. The slight excess of air means all the petrol is burned to achieve maximum efficiency. These economic proportions are used at medium engine speeds. Power proportions equate to a rich mixture of 1 for every 12. The richness of the mixture ensures quick combustion and thereby a greater engine torque. These proportions are used during power requests. Enrichment programming is also applied in the following situations: when idling to compensate for the cylinders not being properly filled, when cold starting to compensate for condensation of the petrol in the mixture. On multi-point injection systems, there are 3 injection methods. With simultaneous injection, all the injectors are actuated at the same time. With semi-sequential injection, the injectors are actuated in twos. In sequential injection, each injector is actuated independently. The last distinguishing criterion is the point where the fuel is injected. With an indirect injection system, the petrol is injected before the inlet valve. With a direct injection system, the petrol is injected directly into the combustion chamber. A fuel supply system comprises the following components: a reservoir, a fuel pump, a filter, a regulator, a rail, and injectors. The fuel pump sucks up the fuel from the tank and feeds the circuit. The fuel pump provides the fuel flow. The fuel filter removes impurities that could damage the sensitive parts of the circuit. The regulator maintains a suitable fuel pressure in the supply circuit. This fuel pressure is also known as injection pressure. The rail distributes the fuel to the injectors. The injectors spray the fuel into the air inlet circuit. The fuel supply systems are sensitive to impurities. Contamination by impurities may lead to a component sticking or leaking from its seals. The cleanliness principles must be applied from the fuel filter to the injectors. The cleanliness advice is described in the technical documentation. The role of ignition is to initiate combustion of the air-petrol mixture at the most favourable moment. Combustion converts the air-petrol mixture into calorific energy. Increasing the heat raises the pressure in the combustion chamber. This pressure increase moves the piston. Engine combustion occurs in 2 phases. Initiation brings a spot of the mixture to a sufficiently high temperature to cause ignition. Flame front propagation ignites the mixture in successive layers. The combustion of the mixture is not immediate. There are around 2 milliseconds between initiation and complete combustion. This combustion time affects the ignition process, as we will see. If combustion is initiated at top dead center, TDC, the pressure caused by combustion is at its maximum after the piston has already gone downwards. The force exerted on the piston therefore only applies in part of the power stroke. The torque produced is low. If, on the other hand, ignition comes before TDC, combustion will be complete at TDC. The pressure due to combustion will be at its maximum and will apply throughout the power stroke. The torque produced will be more important. So, combustion needs to be initiated before the end of compression to achieve the greatest efficiency. Ignition before TDC is known as ignition advance. We will now look at faults that can affect combustion. In the case of explosive combustion, combustion begins normally. But after the pressure increase, the mixture not touched by the flame heats up rapidly as a whole. Explosive combustion is facilitated by too low an octane rating for the engine compression rate. Self-ignition is the spontaneous combustion of the mixture before the spark appears. Self-ignition is caused by excessive compression, which raises the temperature of the mixture above the spontaneous ignition threshold. Pre-ignition is the uncontrolled ignition of the mixture before the spark. This occurs on contact with a combustion chamber hotspot. This hotspot may be due to too hot a sharp edge, spark plug electrode, or exhaust valve. All these combustion faults lead to random combustion. When two flame fronts meet, a shockwave known as pinking is produced. Pinking causes sudden overheating that may melt the spark plug electrodes or the piston head. An ignition circuit comprises the following components: a switch, a coil comprising two windings, and a spark plug. The switch can be actuated mechanically, controlled by an ignition power module, or computer controlled. If there is just one coil, ignition is distributed to the spark plugs. In the case of static ignition, there is one coil for every one or two cylinders. There are two circuits: the primary circuit and the secondary circuit. Click on the switch to see ignition in operation. While the coil is charging, the primary circuit is closed. The switch opens. The opening of the primary circuit generates a high voltage in the secondary circuit coil. On recent systems, the injection computer also manages the ignition function. However, on certain systems, the primary circuit switch is built into an ignition power module, IPM. The IPM manages the coil charge current strength. The computer sends a control signal to the IPM, which opens the primary circuit to initiate ignition. The spark plugs operate at temperatures between 350 and 850 degrees Celsius inclusive. It is essential to fit the spark plugs recommended by the manufacturer. In fact, the thermal range of a spark plug determines its heat extraction capacity. If the spark plug does not extract enough heat, it will stay hot and may cause pre-ignition. If the spark plug extracts too much heat, it will not be at the correct temperature and will be choked. Besides visually checking the condition of the spark plugs, they should be replaced in accordance with the recommended replacement periods. The clip oscilloscope enables you to view the curve of the secondary circuit signal. The oscilloscope shows the following information: the coil charge, the ionization voltage, the spark duration, and the spark gradient. The ionization voltage corresponds to the voltage required to initiate the spark. The spark gradient is due to the increasing pressure in the cylinder that impairs the spark. These parameters may be used to produce a diagnosis. Several factors can affect the ignition curve. These factors are richness, pressure in the combustion chamber, or the gap from the spark plug electrodes. For example, if the gap from the spark plug electrodes is increased, the ionization voltage required for initiation needs to be higher. But since the energy available on the coil remains the same, discharging occurs more quickly. The spark is shorter. The anti-pinking function optimizes the ignition advance without adversely affecting the engine. This function uses the following components: the pinking sensor, the flywheel sensor, and the ignition coils. The pinking sensor is a piezoelectric sensor screwed onto the cylinder head or engine block. Click on the sensor to see it in operation. First, let's look at the program applied in case of non-destructive pinking. The computer determines an ignition advance in line with the operating parameters. If the computer detects non-destructive pinking on a cylinder, it delays ignition 5 degrees on the cylinder concerned. The computer then gradually returns to the initial advance. This correction cannot be viewed on the clip. Now, let's look at the program applied in case of destructive pinking. The computer determines an ignition advance in line with the operating parameters. If the computer detects destructive pinking on a cylinder, it delays ignition 5 degrees on the cylinder concerned. But the computer also preventively delays ignition 1 degree on the other cylinders. The computer then gradually returns to the initial advance minus 1 degree on the cylinder concerned. All the cylinders return to the initial advance after a determined period. This correction can be viewed on the clip. Welcome to the pre-training program for the Petrol Engine Management Checking module. This pre-training will provide you with the knowledge necessary for participation in the course at the training center. The purpose of engine management is to inject and ignite a precise quantity of petrol in the combustion chamber. This operation must respond to the driver's requests while observing the various depollution standards. The injection computer is at the core of this system. The injection computer is connected to many different components. The injection computer receives information from the sensors. The injection computer controls the actuators. The injection computer exchanges information with other computers. On recent vehicles, injection computers may require programming. Programming is only carried out when installing a new computer. Reprogramming a computer can be used to resolve an identified problem or update the software. Also, when installing a new computer, a number of programming operations need to be carried out, such as programming the immobilizer code. Since the immobilizer code programming is permanent, carrying out tests with injection computers borrowed from the parts department and that need to be returned is prohibited. The power supply function is used to power the computer and certain actuators when the ignition is switched on. The oscilloscope shows the following information: the positive after ignition feed signal and the power supply relay. When the ignition is switched on, the computer receives a positive after ignition feed signal from the ignition switch. The computer activates the power supply relay, the coil charge. When the ignition is switched off, the computer deactivates the relay after a certain delay. There is no defect mode programming for the power supply function. If the positive after ignition feed signal does not reach the computer, the power supply relay is not activated. The fuel supply function supplies the fuel pump in line with the necessary conditions. This function uses the following components: the positive after ignition feed signal, the engine running signal, the immobilizer signal, the impact signal, and the fuel pump supply relay. The injection computer controls the fuel pump via a relay. So the injection computer cannot control the fuel pump electrical circuit. On non-multiplex vehicles, an inertia switch is used to open the circuit and cut the fuel pump supply in the event of impact. The fuel pump supply relay is activated when the following conditions are all met: the ignition is turned on, the engine is turning, and the immobilizer is inactive. In the event of an impact, the airbag computer sends a signal to the injection computer, which cuts the fuel supply. There is no defect mode for the fuel supply function. Any fault with the input signals will prevent control of the fuel pump supply relay. The injection function is the fundamental function of an injection computer. This function actuates the injectors at the right moment and for an appropriate length of time. This function uses the following components: the flywheel sensor, the manifold pressure sensor, or the air mass flow meter, and the injectors. The manifold pressure sensor is a piezo-resistive sensor. This sensor tells the computer the air pressure in the inlet manifold. The air pressure is used to calculate the mass of air in a given space. This information, combined with the engine speed, enables the computer to determine the quantity of petrol to inject. The air mass flow meter is used on certain systems instead of the manifold pressure sensor. This sensor measures the mass of air entering the engine. This measurement, combined with the engine speed, enables the computer to determine the quantity of petrol to inject. Injectors behave like solenoid valves. The injectors receive a plus 12 volt supply via the power supply relay or the protection and switching unit. Click on the injector to see it in operation. The computer sends a mass to the injectors in sequence to control them. The injection correction function is used to adapt the injection duration in line with several parameters. This function uses the following components: the manifold pressure sensor, the coolant temperature sensor, the air temperature sensor, the battery voltage signal, and the injectors. Atmospheric pressure decreases with altitude. This results in a decrease in inlet pressure and the mass of air entering the cylinder. The computer stores the information provided by the manifold pressure sensor when the ignition is switched on as the atmospheric pressure. The injector opening time is corrected in line with the following parameters. If the atmospheric pressure decreases, the injector opening duration decreases. The computer uses the coolant temperature information to apply enrichment programming when the engine is cold. Air density depends on its temperature. The computer uses the air temperature information to correct the calculation of the mass of air entering the cylinder. The injector power supply affects the actual opening duration of the injectors. The computer uses the battery voltage signal to compensate for this changing value. In In the event of a manifold pressure sensor fault, the atmospheric pressure signal is ignored. There are several defect mode programs for the coolant temperature sensor, depending on the system. The computer may, for example, use the air temperature value when starting and then take a hot engine temperature value. There are also several defect mode programs for the air temperature sensor, depending on the system. The computer may, for example, take a programmed value of 20 degrees Celsius. There is no defect mode for the battery voltage, as this signal is taken directly from the computer supply circuit. The idle speed regulation function is used to adjust the airflow required to maintain the idling speed. This function uses the following components: the flywheel sensor, the accelerator pedal position sensor or throttle position sensor, the coolant temperature sensor, and the idle speed regulator. Idle speed regulation is active when the computer receives the no-load signal. Depending on the system, this signal may come from the following two sensors: the throttle position sensor on cable accelerator systems, or the accelerator pedal position sensor on vehicles equipped with a motorized throttle valve. Welcome to the pre-training program for the Petrol Engine Management Checking module. This pre-training will provide you with the knowledge necessary for participation in the course at the training center. Under ideal conditions, engine combustion would only produce water and carbon dioxide. However, combustion is not perfect and produces various pollutants. Click on the vehicle to see the various pollutants. There are various causes of pollutant production. Pollutants are considered as harmful. Pollutants have impacts on health: irritations of the respiratory tracts and eyes, faintness, muscular weakness, etc. These pollutants cause the pollution fogs known as smog and acid rain. Pollutant emissions are governed by increasingly restrictive anti-pollution standards. You can see how these standards have changed on the graph. Exhaust gas analysis is used to check the conformity of the vehicle with the standards. This analysis, in association with the clip, can also be used for injection system fault finding. The oil vapor rebreathing system is used to recycle fuel vapor contained in the oil. It generally comprises two distinct and calibrated circuits. Click on the throttle valve to see operation at low load. The petrol vapor rebreathing system is used to recycle the fuel vapor contained in the tank. This system uses the following components: the coolant temperature sensor, the flywheel sensor, the throttle position sensor, and the purge solenoid valve on the petrol vapor canister. The petrol vapor canister is a component able to store petrol vapor from the tank. The petrol vapor canister uses activated charcoal that acts as a petrol vapor sponge. Click on the canister to see the system in operation. Any fault with the petrol vapor rebreathing system components will stop the function.